Hello and welcome back to the MCAT grind. We have chapter 9 for general chem. Now, solutions are a bit of a whack because of the solubility rules. Thankfully, you don't need to know all of them. Just generally, group 1, all the alkali metals plus NH4, all of them combined with another compound are water soluble. So that comes as an exception for many of the other ones too. NO3 and acetate binding to will also be water soluble. Anything binding to chloride, bromide, iodide is water soluble except with silver, lead, and mercury. Anything binding to sulfate is water soluble except for with calcium, strontium, barium, and lead. Metal oxides are insoluble except with calcium oxide, strontium oxide, and barium oxide, or alkali metals. Anything hydroxide is also insoluble. Think about NaOH, right? Except with calcium hydroxide, strontium hydroxide, barium hydroxide, or alkali metals. So you can see a similar pattern here. Alkali metals, whatever they bind to, are water soluble. The carbonate and phosphate, as well as sulfate, sulfide is insoluble except with alkali metals or ammonia. The concentration to sulfur equations usually use molarity, mole per liter. That's like the biggest thing you'll need to work with. This also equals to M, big M. Alright, so you have the molarity times the volume will be the same before and after. So you can use that to solve many equations. You have percentage by mass, mole fraction, molality, which is over kg. They'll usually be the same at standard 25 degrees temperature, except when it's boiling point or freezing point. Normality is a number equivalence over the liter. So if you have H2O, you have 2H, right? So if you have 1 molar of concentrated H2O2, then that's basically 2 normals of H, because there's 2 hydrogens every that 1 molecule. Equilibria uses this equation, basically KSB, the solubility constant, based on the molecule itself. The solubility for that is just in the format of A to the M to however constants it has. And when you solve for KSP, this is the general forms they have, right? Because Kx, if it's x squared, is just x by itself, right? They all have equal concentrations. But if one has a squared, right, if it's x squared, then you have x times x, and there's 2 of it squared, because you need to make 2 of this for every one of this, and that squared comes down to here, so 4x cubed altogether. This you have x times 3x, because you need 3 of this for every x, so that comes out to a KSP formula of 27x to the power of 4. The common ion effect is when you change the KSP, new solubility, whether it increases or decreases. Remember, if it has a higher than this KSP value, then it's going to turn into a solid in a solution. It's going to turn insoluble. And if it's less, then it's going to be a dilute, and it's going to keep making, it's going to have a homogeneous solution. Osmotic pressure depends on what we said in normality also. So you have NaOH, then that's two ions that's going to dissociate. So that's what I is. M is the concentration, R gas constant, and temperature. Alright, that's pretty much it.